Let's summarize the module. And for this one, I'd like to do it diagrammatically because it puts everything in really good perspective. So let's look at it like this. We have an attacker. When the attacker makes a request to the web app, putting it through a WAF or an IDS can be a great first line of defense. If the attack can be stopped before it even hits the downstream app, then that's a great position to be in. Downstream of there, we have the website. And as we just saw in the last clip, the website should be modern and should be patched. Modern web server, modern web software, all up to date. Now within this web app, one of the really critical things we discussed at the start of this module is whitelisting and custom error messages. Custom error messages, of course, being error messages that are tailored for the user and built as part of the app, not the underlying internal exceptions exposing the implementation in the app, particularly when they expose exceptions that bubble up from the database server. Now with all that being good, the website should be creating parameterized queries, so using inline SQL with parameters, or stored procedures, or object relational mappers. Anything which parameterizes is a good thing. And again, let me reiterate, that is really the heart of SQL injection, getting queries parameterized. Now really, when the web app sends this query off, it should be going through a firewall. You want to try and have your web app isolated from your database server. The web app obviously has to be consumer facing. It's normally going to be in a public network segment. That doesn't mean that your database has to be though. It simply means that the web app has to be able to connect to your database. And that can be through a firewall that keeps everything else out. When that web app does connect through to the database, we want to see a non-privileged account. So this is where we looked at that principle of least privilege, making sure the account the web app uses can do only what it needs and nothing more. And then ultimately, of course, it'll actually be hitting the database, which should also be modern and patched. And you'll get all the nice security features that organically happen with each new release of database management servers, not to mention all the fixes for actual flaws that have come out via patches. The only other thing we discussed that's worth mentioning here, and again it's a bit subjective, is this idea of having a service tier. So an abstraction between the web app and the database, such that the web app is never actually preparing and sending SQL statements itself. Approach that with caution. Think about whether it actually makes sense to the broader architecture of the app, and don't get too caught up in the utopian thinking that there needs to be this segmentation in there. So that's the whole picture. Apply as many of these as you can, think about defense in depth, and SQL injection risks will become a thing of the past.